So 6.5, solving square root and other radical equations. So for this section, we're going to jump right into the problems. You're going to realize we're going to use a ton of stuff from earlier Algebra 2, Algebra 1, just a lot of previous knowledge that you need to be able to solve these, but you have all of the skills necessary to do this. So we're going to look at it, jump right into the examples, okay? And I got kind of over here already written down how we're going to do this, just so that they're there for you. You can pause it and write it down as we do that. But to look at this, so given this problem, I want to know what the solution is. So what we're trying to do is get this x right here by itself. So we have to go through our inverse operations. The first thing we need to do is get the root by itself. Okay, in this case, it's a square root. So I'm going to get this entire square root symbol by itself. So I need to subtract the 3. Okay, this will cancel here. That leaves me with the square root of 2x minus 3 is equal to 8 minus 3 is 5. Once I have the root by itself, I need to get the radical to disappear. So to do that, I'm going to square both sides. Now, if this was a cube root, I would cube it, both sides. If it was a fourth root, I would fourth power, raise each side of the fourth power. So notice how I'm saying get the root by itself. In this case, it happens to be a square root. Well, on the left, all that happens is the square and the square root disappear. So I'm left with a 2x minus 3. On the right, I actually have to do this math right here. What is 5 squared? Well, it's equal to 25. Now I have a simple linear algebraic problem like we did at the very beginning of this chapter, or the very beginning of this book, and I solve for x. So I'm going to add 3 to both sides. 2x equals 28. I'm going to divide by 2, and I'm going to get x is equal to 14. And divide by 2, not 14. So divide by 2. So right there, there's my answer. X equals 14. If I take 14 and plugged it in here, 2 times 14, 28. 28 minus 3 is 25. The square root of 25 is 5. 3 plus 5 is 8. So you can always check doing the left side equals the right side. Okay, so now if you have a radical equation that looks like this, and I have an exponent that's written as a fraction, I'm going to do the same thing. I want to get whatever's being raised to the exponent. So get whatever's being raised to the exponent, or get the radical by itself. Okay. Again, a fractional exponent is just a radical. So I need to move this 3. The one thing I want to make sure I tell you is do not distribute. Too many times I'll have students that try to solve this and say, well, 3x plus 3 raised to the 2/3 power. This is a huge no-no. Do not distribute that. I need to get it to the other side. So I need to divide by 3. And that will leave me with x plus 1 is raised to the 2/3 power is equal to 4. So now I'm going to raise both sides to the reciprocal power. Okay, so I'm going to raise each side. So I'm going to raise each side to the 3/2 power. On the left, again, the whole point of that is to get the exponent to cancel, and I'd be left with x plus 1. On the right, I've got to rewrite what this says. Remember, index goes on the bottom. So this is the same thing as the square root of 4. I'm going to write that differently. Okay, the square root of 4 to the 3rd power. So this is x plus 1 equals, what's the square root of 4? 2. 2 to the 3rd power is 8. So I have x plus 1 equals 8. I subtract 1, and I get x is equal to 7. So when I have a radical that's raised to, or a problem that's raised to a exponent, I'm going to get that, whatever's in parentheses, by itself. And I'm going to raise both sides to the reciprocal power. And when I raise each side of the reciprocal power, I'm always going to be able to simplify the number on the right. Okay, let's take a look at another example here. So again, I need to get the radical by itself. So I'm going to subtract 1, 3 5th root of x plus 1 cubed equals 24. I'm going to divide by 3. I've got the 5th root of x plus 1 equals 8. At this point right here, sorry, let's raise the 3rd power. I'm going to rewrite this as a fractional exponent. This is the same thing as x plus 1 raised to the 3/5 power. Okay, well, I can also write this as 8 to the 3/5 power. Now, how do I, sorry, no, I'm not doing that. My mistake. Go back. Okay, there we go. I'm keeping the 8 the same. I haven't done anything. All I did was rewrite the left side. So I don't need 8 to the 3/5 power. That's just 8 over here. Okay, so all I did was, again, rewrite this using this formula here where I had A over, A to the M over N is the same thing as the nth root of A raised to the M power, back from our earlier sections in chapter 6. So now, how do I get rid of a fractional exponent? I raise each side to the reciprocal power. So I've got x plus 1, right? This cancels. What does this really mean? It means the cube root of 8 raised to the 5th power, where the cube root of 8 is 2, and then 2 to the 5th power is 32. So then I subtract 1, and you get x is equal to 31. So you're going to have a few problems like this. Again, I'm trying to shorten the load of homework, so make sure the problems where I give you one, you do that one problem, and if you've got questions, you ask. Now they get a little bit harder here, okay? So we have something where we have to check for an extraneous solution, which means I do all of the math right, and at the end of it, it doesn't end up working. So I'm going to go ahead and get the radical by itself. So I'm going to add 5. So that will leave me with the square root of x plus 7 equals x plus 5, right? I can't combine those. So at this point right here, this is where you need to pay attention. I'm going to square both sides. On the left, easy peasy. Cancels the radical. On the right, I actually have to do x plus 5 times x plus 5. So I have to FOIL this out. So the left is going to stay x plus 7. This is going to give me x squared plus 5x is a plus 10x. 5 times 5 is 25. So now I'm dealing with a quadratic. So I need to set this equal to 0 and factor it to solve. So I'm going to subtract x, subtract 7, and that will leave me with 0 equals x squared plus 9x plus 18. So then now how do I factor this? I'm looking for two numbers that multiply to 9x and add to 18. Back from chapter 4, so it'll be x plus 6, x plus 3. And then I use the zero product property, which says I set x plus 6 equal to 0 and subtract 6. So I would get negative 6. I set x plus 3 equal to 0 and x is equal to negative 3. So I did all that math. Everything done here is correct. Now I need to go back and check that these answers are correct. Okay, I cannot get a negative, so I have to make sure that when I plug this in, it works. Right, so negative 6 plus 7 is 1. 1 minus 5 equals negative 4. I just plugged in negative 6. Does negative 4 equal negative 6? No. So negative 6 is what we call an extraneous solution. If I plug in negative 3, and again, all I'm doing is plugging in negative 3 plus 7, all underneath the square root, minus 5 equals a negative 3. Negative 3 plus 7 is 4, right? 2 minus 5 equals negative 3. Negative 3 equals negative 3. And you can use a calculator to show that the right side equals the left side. And that shows that that is definitely correct. Okay, so again, got another problem here where we're going to check for an extraneous solution. This problem gets a little bit harder just because when you have two radicals, you have to get them on both sides. So I've got the square root of 2x plus 1 is equal to the square root of x plus 1. Okay, so I'm going to sit here and say, well, I want to get rid of the radical, right? So I'm going to square both sides. So on the left, 2x plus 1. On the right, I'm left with the square root of x plus 1 times the square root of x plus 1. Okay, so I'm going to actually have to make sure that I simplify this and FOIL it correctly. So the square root of x times the square root of x is x. My outside gives me the square root of x. My inside gives me the square root of x. And my last terms gives me 1 times 1, which is 1. So when I rewrite this, 2x plus 1 equals, look what I have here. I've got x plus 1 plus the square root of x plus the square root of x is 2 square root of x. So to do this problem, I've got to redo everything and get the radical by itself again. So I need to get all of these terms over to this side. So I'm going to subtract x. I'm going to subtract the 1. So I'm left with 2x minus x is x. 1 minus 1 is 0 equals 2 times the square root of x. At this point, I can square both sides again. So I've got x squared equals, make sure you square both of those, 4, and the square root of x squared is just x. So this is the same thing as, so this is equal to, sorry, that got rid of my radical. So now I'm left with x squared equals 4x. I'm going to subtract 4x and set it equal to 0. So I've got x squared minus 4x equals 0. I'm going to factor out an x. It's going to give me x minus 4 equals 0. I use the 0 product property, and I get x equals 0. That comes from this factor right here. And then I set x minus 4 equal to 0, which I just add 4, and x is equal to 4. So I get my two solutions here. I need to, again, check them. If I plug in 0, 2 times 0 is 0, plus 1 would give me the square root of 1, which is 1, minus the square root of 0, which is 0, right? So 1 minus 0 equals 1. So when I plug in 0, it works. What happens when I plug in 4? 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. Plug in 4. Square root of 4 is 2. 3 minus 2 is 1. 1 equals 1. So in this problem, I get two solutions. So again, when you do this and you see two radicals, first of all, you have to get the radical, one of the radicals on the left and one of the radicals on the right. Okay? So we get both of those on either side. We're going to square both sides. When I do the process and do all of the algebra, I'm going to be still left with a radical. I need to do it all over again, get the radical by itself, and then square both sides. Okay, those problems can be a little bit confusing. Again, if you've got questions, make sure you're asking, but this is 6.5.